Now let's see the third type of trigonometric equations and their general solutions. These equations are given here, that is sin square theta equal to sin square alpha, cos square theta equal to cos square alpha, and tan square theta equal to tan square alpha. Let's consider the first one, that is sin square theta equal to sin square alpha. So with the usual diagram, we consider some arbitrary angle, say alpha, right? So alpha is of course the solution, one solution of the given equation, that is sin square theta equal to sin square alpha. Now as we saw earlier, the angle which is symmetrically opposite, that is pi minus alpha, right, this also has the same sign as that of the original angle alpha, so therefore its square will also of course be the same. Now since sine is getting squared, we can allow the negative value of sine alpha also, isn't it? So therefore here the angle is nothing but pi plus alpha, and there will be another symmetrical angle here which will also have minus sine alpha as the sign, and that angle is nothing but 2 pi minus alpha. So as we can see, basically it is the angle which is less and more by the value alpha than the integer multiples of pi. So therefore after 2 pi minus alpha, the next angle in sequence is 2 pi plus alpha, and so on. So we can see that theta is nothing but integer multiple of pi, you see, 1 pi, 2 pi, and so on, and with which we have both the values as the possible solution. So we have to make room for plus or minus alpha, and that becomes the general solution, right? So therefore theta is equal to n pi plus or minus alpha is the general solution of sin square theta equal to sin square alpha. Now interestingly, we can confirm that the same solution applies to the remaining two equations also, simply because they also have the same structure of squaring. So whether it is positive cos, which is on x coordinate, or negative cos, which is on negative x axis, the squares of that cos alpha will always be the same. So whether it is cos alpha or minus cos alpha, their squares will always be non-negative and same. So therefore for all the three equations shown here in this third type, the general solution is exactly same, which is theta given by n pi plus or minus alpha. Right. Let's move on to the next type, that is type 4. Now here we have to consider a single equation as shown here, that is a cos theta plus b sin theta equal to c, where absolute value of c is less than or equal to root of a square plus b square, and a, b, c are basically nothing but some real numbers, right? So with that we have to solve this particular equation. Now here what do we do is we divide throughout by the particular quantity root of a square plus b square. So let us see what happens when we divide this and why do we do that. So on dividing we get a cos theta plus b sin theta whole divided by root of a square plus b square is equal to c upon root of a square plus b square, right? Now I just rearrange this left hand side, writing cos theta first and writing the other factor, that is a upon root of a square plus b square, plus the next term is sin theta multiplied by the remaining factor, that is b upon root of a square plus b square is equal to c upon root of a square plus b square. Now if we look at this particular quantity, that is a upon root of a square plus b square, let us ask the question, where does or where can this particular quantity come into picture? So if we look at the term root of a square plus b square carefully, we can imagine that it is nothing but the hypotenuse of some right angle triangle in which a and b are the two perpendicular sides, right? So if a and b are two perpendicular sides of a right angle triangle, then hypotenuse has to be root of a square plus b square. So now if we look at this particular fraction, that is a upon root of a square plus b square, and if we imagine some angle theta in the right angle as shown here, then from the perspective of theta, the fraction a upon root of a square plus b square represents the cos component, that is the cos of theta, and immediately b upon root of a square plus b square, which is the second term, represents the sine of theta, right? So there will always be some angle theta or alpha. Of course here we will not call that as theta, we will call it as alpha, where cos is given by a upon root of a square plus b square and sine is given by b upon root of a square plus b square, correct? So that is how we write the further step, by saying that let a upon root of a square plus b square is equal to cos alpha, right? Which implies that b upon root of a square b square is sine alpha. Now we also assume that this particular right side quantity, that is c upon root of a square plus b square, to be equal to cos of some angle. So let's call it as beta, right? We cannot say that it has to be alpha only, so we choose a different symbol in general, that is beta. So therefore rewriting, we get cos theta into the first bracket in the first term is nothing but cos alpha, so that is cos theta cos alpha plus sin theta sin alpha is equal to cos beta. So now we can see that left hand side is the expansion of cos of theta minus alpha is equal to cos beta. Now if we recollect, here we are getting the equation of type 2, isn't it? Cos of theta minus alpha, that is some angle, is equal to cos of beta, which may be some known angle or whose cos we know. So therefore the general solution is theta minus alpha is equal to 2n pi plus or minus beta, correct? So therefore taking alpha on the other side, we have theta is equal to 2n pi plus alpha plus or minus beta, where n is an integer, correct? So therefore this is the general solution of the given equation a cos theta plus b sin theta equal to c. Now we have to remember that if this particular condition is not met, that is if c is not numerically less than root of a square plus b square, then the solution of this equation does not exist. Alright, now let us solve one example based on this last type. Find general solution of cos theta minus root 3 sin theta equal to 1. So if we recollect, it is of the fourth type, that is a cos theta plus b sin theta equal to c. Now to solve this particular equation, we follow the same steps as we did while deriving the general solution. So if you remember, it is nothing but we have to divide by the term root of a square plus b square, which is nothing but root of, now a is here 1 by comparing, plus b is nothing but minus root 3 the whole square, right? So that is nothing but root of 1 plus 3 which is 4, so therefore root 4 is 2. So therefore dividing by 2 we get cos theta minus root 3 sin theta whole upon 2 is equal to 1 by 2. So therefore rewriting, we have cos theta into 1 by 2 plus sin theta into minus root 3 by 2 is equal to 1 by 2. Now if you remember the term that is attached with cos theta, we have to write that as cos of some angle, but that angle should be such that the sine of that angle should be equal to minus root 3 by 2. So cos has to be 1 by 2 and sine has to be minus root 3 by 2. Now which is that angle? If we think about it, then suppose we say that cos theta is 1 by 2, so therefore it has to be 60 degrees, but that will be wrong, because for 60 degrees sin theta will be equal to plus root 3 by 2, right? So that means, let us imagine it, if theta we wrongly wrote as 60 degrees, we would have got the sine as positive, but we want sine as negative, keeping the x coordinate, that is cos, same. So therefore we must consider the angle minus 60 degrees where the sine will be negative, correct? So here we have to write cos of minus pi by 3, and here we have to write the sine of minus pi by 3. I forgot to write the sine, so it has to be sine of minus pi by 3. On the right side, if you recollect, this term we have to write as cos of some angle, cos of the smallest known angle. So therefore here we can write that as cos of 60 degrees, so that we can write as cos of pi by 3, right? So therefore left hand side is the expression, the expansion for cos of first angle minus second angle. So it is cos of theta minus pi by 3 is equal to cos of pi by 3. So we have cos of theta plus pi by 3 to be equal to cos of pi by 3. So therefore we have to now write the general solution of this equation, which is of the form cos of theta is equal to cos of alpha, which we did as the second type of the equation. So therefore its general solution is given by theta plus pi by 3 is equal to 2n pi plus or minus the angle on right side, which is alpha. So here it is pi by 3. So therefore at the end we can write theta is equal to 2n pi minus pi by 3 plus or minus pi by 3. So therefore if you consider plus sign, then pi by 3 and pi by 3 will get cancelled. So in that case what remains is just 2n pi, and if you consider minus sign, so then we have minus pi by 3 minus pi by 3, which is minus 2 pi by 3. So we get another possible expression or the solution as 2n pi minus 2 pi by 3. So therefore here is the general solution of the given equation, and n has to be an integer.